Hello class, this is Mr. Lehman. Today I want to continue our discussion. I want to take a look at a couple things. So the thing we're going to look at today is to try to figure out how much excess reactant is left over. So the last tutorial we learned how to figure out which reactant was called the limiting reactant, which one runs out first, and we figured out which one is the excess reactant, which one do we have extras of when we're all done. So we're going to look at a reaction. The same reaction is in your white unit packet, and we established that 3 silicon atoms plus 2 nitrogen molecules will combine through a synthesis reaction to make trisilicon tetranitride. Alright, so let me highlight these coefficients in red so they stand out so we can determine the correct mole ratios. And we have a 3 to 2 to 1 ratio. Once again, you don't have to write the 1, but sometimes it's nice when you're doing mole ratios, stoichiometry, to have that there. So the question from our packet is this. We have 602.25 grams of silicon reacting with 493.71 grams of nitrogen, and our job is to figure out how many grams of product will form. Alright, so remember, limiting reactant problem, we have to look at how much each reactant is able to produce separately. So we have two different setups, two different stoichiometry problems to take care of. So let's start out with the silicon. So 602.25 grams of Si. We take what we know, we put it over top of 1. We got to convert that into moles, and so 1 mole of silicon is 28.09 grams. Alright, we're converting into product, and so the mole ratio, 1 mole of product can be produced by every 3 moles of silicon. So there's a 1 to 3 ratio. So we're going to basically make 1/3 the number of moles of the product as we start out with the reactant. And then finally the molar mass. The molar mass of 3 silicons, 3 times 28.9 plus 4 nitrogens at 14.01 apiece is equal to 140.31 grams per 1 mole. Alright, check units. Do they cancel? Yes. Moles? Yes. Moles of product, moles of product. So let's go ahead, crunch some numbers, pause it, see what you get, and come back. Alright, the answer, sig fig wise, so we have 5 sig figs, 4 sig figs, 5 sig figs. We're only going to have 4 sig figs in our answer. So we get 1,003 grams of product based on this one. So now we have to look at the other reactant. Alright, so we got to look at nitrogen now. So we're going to take 493.71 grams of nitrogen, do the same process, convert into moles. So 1 mole of N2 is 2 times 14.01 or 28.02 grams per mole. The ratio is 1 mole of product can be made for every 2 moles of reactant. And the last step, we want to figure out how many grams of product we're making. So we already determined the molar mass, 140.31. And so to save a little bit of room here, I'm not going to write the units for that last one. I apologize for taking a shortcut. I just don't want to have to scroll when we look at the numbers. So units are canceling. And as an answer, we get 1,235 grams of product. Now, we only can pick one as an answer, so which one's smaller, that's how much we can make. And so 1,003 grams is indeed the answer. So we determined that the silicon is the limiting reactant, and we determined that the nitrogen, which can make more, 1,235 grams, is in excess. So there's going to be some nitrogen left over. So the final sort of step to this is, alright, well, how much nitrogen, how much of that 493.71 grams is left over? And so in your notes there's an outline of how to determine this. So typically what I like to do, you can go from product back into excess, but I like to go start out the limiting, and from the limiting figure out how much excess you can make. And what I mean by that is 602.25 grams of silicon are going to react to make 1,003 grams of product. So I know I used up all of this, so I can take the grams of silicon that reacted, use that to figure out how many grams of nitrogen I need to go along with it. So that is the process that I am going to take. So instead of scrolling, let me go ahead and try to copy all this information and put this on the next slide. Alright, so most of it copied over. Some of it gets a little bit crazy and offset. Alright, so let's do it. Let's figure out how much nitrogen is left over. So take the amount of the limiting reactant that was used up and put it over top of 1. And then we're going to convert into moles like we always have to do. And 1 mole of silicon, as we established before, is 28.09 grams. The ratio, what we are currently in, what we're currently working with, is SI. So that goes on the bottom. So 3 moles of silicon are required for every 2 moles of nitrogen. So our ratio is 2 to 3. Because we're trying to figure out how much of this 493 grams we're using in our experiment. And then the last step then is to convert back into grams, and so as we established before, 28.02 grams per mole. Alright, so we're starting out with grams of limiting reactant that we use. We convert it into moles. Moles of limiting multiplied by the ratio to convert into moles of excess, multiplied by the molar mass, and from here we determine that we have 400.5 grams of nitrogen that was used up. So the answer to this problem is how much was used up, how much is needed. And so what we can do is figure out how much is left over. Take, well, how much did we start with? Subtract how much was used up. The difference is how much is left over. And we get about 93.2 grams. Because this number only has 1 decimal place, we can only have 1 decimal place in our answer when we subtract. If you remember the rules of sig figs. Alright, so that's how much we have left over of the nitrogen. Alright, so I hope this helps. We got one more tutorial left this unit. That is on percent yield and percent error. So have a great day.